In which compound is the percent composition by mass of chlorine equal to 42%? Well, they've given you the gram formula mass of each of these compounds, which is very handy to have. Makes the calculation easy. All I need to do is look up how much the formula mass of chlorine is. Chlorine is 35.453. So where is the mass equal to 42%? Well, 35.453 divided by 100 is going to be not 42%. I'll show you. 35.453 divided by 100, 0.35453. Let's try this. 35.453 divided by 68. 52%. Let's try the next one. 35.453 divided by 84 equals 0.42. I know that if I multiply by 100, that's 42%. So it must be this one. Remember that percent composition by mass is just equal to the mass of the element, X, whatever it is, over the mass of the molecule, or the whole formula, times 100%. If you're like me, you'd multiply by 100% in your head. What is the molecular formula of a compound with an empirical formula of P2O5 and a gram molecular mass of 284 grams? Well, the first thing to do is to figure out what the molar mass of P2O5 is. P in the periodic table is 30.974 and O is 15.999. Multiply this by 5, multiply this by 2. 30.974 times 2 plus 15.999 times 5 equals 141.943. Now all we have to do is figure out this ratio. 284 divided by 142 is just 2. So every one of these subscripts will be multiplied by 2. 2 times 2 is 4. 2 times 5 is 10. So the answer must be B. Number 30. What is the empirical formula of a compound that has a carbon to hydrogen ratio of 2 to 6? Well, if the carbon and hydrogen ratio is 2 to 6, since both of these numbers are evenly divisible by 2, this would be the empirical formula. The chemical equation below is unbalanced. What is this coefficient of O2 when the equation is balanced correctly using the smallest number of coefficients, whole number of coefficients? So let's take a look. The first thing we're going to do is look at magnesium. There's one on the left-hand side and one on the right-hand side. So far, so good. Chlorine. There's this one here in the chlorate, but there are 2 chlorates. So there are 2 chlorines on the left-hand side. There are also 2 chlorines on the right-hand side. Still, so far, so good. The last thing we'll do is balance the oxygens. There are 3 in the chlorate, but there are 2 chlorates. So 3 times 2 is 6. If we come over here, we're going to need 3 pairs of oxygen to make 6 oxygen atoms. So our correct answer is C. Here we're just going to count atoms again. If we look at this one, 2 hydrogens on the left side and 2 on the right side, 2 oxygens on the left side, but only 1 on the right side. So this one is not balanced. Here we have 2 nitrogens on the left side and only 1 on the right side. Again, not balanced. 2 times the 1 sodium on the left side makes 2, but only 1 on the right side. Not balanced. Leaves us with F. Let's check and see. 2 times the K, which is potassium, 2 of them on the left side, 2 on the right side. 2 times this 1 Cl is 2 Cls on the left side and 2 on the right side. The correct answer is F. Another equation to balance. NH3, 1 N on this side, 1 N on this side, 3 H's on this side, and 1, 2, 3 on this side. The last one is oxygen. We have 3 here and 1 here for a total of 4 oxygens. So this side of the equation will need 2 pair. It asks you what the smallest coefficient would, whole number coefficient would be. It's 2. The correct answer is D. I think we've seen this one before. This unbalanced equation shows the combustion of methane. CH4 plus oxygen yields CO2 and water. Any combustion reaction has products of carbon dioxide and water. Which series of coefficients represents which series of numbers represents the coefficients necessary to balance the equation? Let's take a look and see. We have 1 carbon on this side and 1 on this side. That's good. We have 4 hydrogens on this side, but only 2 here. So we're going to have to multiply this number by 2. Lastly, we'll look at the oxygens. We have 2 oxygens here. We have 2 times 1 here is 2. So we have a total of 4 oxygens on the right-hand side. We'll need 2 pair here. Normally we don't write 1s in chemistry, but for purposes of answering this question, we'll fill in 1s on the blanks. 1, 2, 1, 2. We look for that here. We find that the correct answer is H. The average atomic mass of chlorine is 35.5 atomic mass units. Which mixture of isotopes, shown as percent, produces this average mass? What we need to do is look at the percentages and multiply them times the atomic masses. I'm going to convert 75% to 0.75 and multiply it by this mass number of 35. Then I'm going to take the 25% and multiply it by the mass number of 37 here. And then I'm going to add these together. I'm going to do it in one step and I'll just show you how. 0.75 times 35 plus 0.25 times 37 equals 35.5. Turns out that this is the correct answer. I'm going to show you another one. Well, first of all, let me just show you this. Notice that carbon has nothing to do with these, so we can get rid of it. If we had looked at 50% of each isotope, this would have been 0.50 times 35 times 37. 0.5 times 35 plus 0.5 times 37 is just an average, and this number would have come out to 36, which would have been the incorrect answer. So chlorine is 75% chlorine 35 and 25% chlorine 37.